Everybody. So today we are expanding on what we did the other day. So the other day we got a really good head start into what's going on. So on this first section we have some basic problems, and one thing with the other day is we looked at it from a 0 to 360 degree scale. Using your unit circle, right below the degrees is the radian measured. So if it's 0, 360 or 0, 2 pi, same idea, same answer, is just written in two different ways. So talking basic here, we got, if we're solving, we have 2 sine x equals negative rad 3, which gives us sine x equals negative rad 3 over 2. So can't forget our ASTC idea. So if we're talking about negative sine, we're quadrant 4 and quadrant 3. Where does sine have a rad 3 over 2 value? We're talking about 60 degrees. But we're in the third and fourth quadrant. So if we look at our unit circle, if we're looking right here, talking about 240 and 300. 240 and 300 are degree answers, but since we're talking in terms of radians, 4 pi over 3 and 5 pi over 3, which are the same answers as 240 degrees and 300 degrees. It just depends on what the domain of the problem actually is. So down here, going from, if I called this a level 1 to a level 2 problem, I add 1 and divide by 3. Cotan x equals 1 over rad 3. Now with our unit circle, we focus on working with sine, cosine, and tan. Well, one thing we learned about if we have cotan, secant, and cosecant is that we can flip it to solve. So if I take cotan and make it tan, that means that 1 over rad 3 becomes rad 3 over 1, which is just rad 3. On our unit circle, we talked about this, so hopefully everyone has this written down, but with 30, 45, and 60, 30 for tan is rad 3 over 3, 45 is 1, and 60 is rad 3. So if we're talking about positive rad 3 here, we got pi over 3 for 60 degrees, and we got 4 pi over 3 for 240 degrees. And again, same idea, radian, degree measure, it's not really different. Same answers, just looking a little different. So let's keep working ourselves up this scale now. Oops, I got stuck on something. So if we call this a level 3. Well, so I got secant squared x equals 1, which means that secant x equals positive negative rad 1. When we have that exponent, we solve, that gives us the positive negative. The nice thing here is that rad 1 is just 1, so we have positive negative 1. We don't work in secant, so we got to work in cos. So if we flip 1, we get 1. So the question is, where is cos 1? Where is cos negative 1? Cos is 1 at 0, or 0 degrees, and it's negative 1 at pi, or 180 degrees. That's also positive 1 at 2 pi, which is 360 degrees. I get the question, do I have to do it in radians? Do I have to do it in degree? It's not right, it's not wrong, it's just, that's what the problem's telling you to do. This says work in radians, so we work in radians. If it was 0, 360, 0, 180, and 360 would be our answers, and that's fine. So again, where are we working with all this stuff? We are working up to this. This is the main idea. This is where our factoring comes into play. So if I take this problem, sine squared x minus 3 sine x, and I add the 2 over. One thing I like to do to help make my life easier is I write something like w equals sine x. By doing this, I help clear out the clutter. W squared minus 3w plus 2 equals 0. Right? Sum product factoring. w minus 2, w minus 1. So w equals 2 and w equals 1. And now that I broke it down as far as possible, I'll bring back in sine. Sine x equals 2, sine x equals 1. Well, on our unit circle, where is 2? 2 is nowhere to be found on our unit circle. And that's because sine is always going to be between -1 and 1. And same with cos. Cos is always between -1 and 1. So we're never going to be able to solve for cos of 10, cos of -5, sine of 4, sine of 8. Never going to happen because it's not between -1 and 1. All right, where is sine 1? X equals pi over 2. Okay, moving on. So looking at this worksheet, we got some good practice problems here. So if I work through some of these, divide by 2, sine x equals 1/2, x equals, all right, where's sine 1/2? We're talking about 30 degrees, and we're talking about 150. But if we're talking between 0 and 2 pi, we got pi over 6 and 5 pi over 6. Okay, that's our most basic one on this page. Getting a little bit more complicated, we have example 2. So we have 2x, and we're going to do everything like we were doing before. So if I add over the cos of 2x, I have 2 cos of 2x. And you know what? If I subtract over the rad 3, I have negative rad 3. If I divide by 2, I have cos of 2x equals negative rad 3 over 3. Negative rad 3 over 2. And the initial thought, people always want to divide by 2. We can't divide by 2. We leave the 2. Now we're going to solve. We're here like, we wrote x equals 150, x equals 30. Because this problem had x alone. This is 2x. So really, we're talking about 2x equals. Well, if we have negative rad 3 over 2 for cos, right, we're talking about cos negative rad 3 over 2, as. So we're talking about 150 degrees and 210 degrees. That's where cos is negative rad 3 over 2. But since we have it as 2x, we divide by 2 and get 75 degrees and we get 105 degrees. And why do we do that? Because since it's 2x, when we plug in, right, cos of 2 times 75, that's where we get our cos of 150, which is negative rad 3 over 2. All right, cotan squared x equals 1/3. Square root it. Cotan x equals positive negative rad 1 over rad 3. Well, if I flip it and know that this is 1, I get positive negative rad 3 over 1, which is just positive negative rad 3. So what does x equal in this situation? We're talking about tan positive negative rad 3 at every single quadrant. Right? So we have 60, 120, 240, and 300. Right, those are the degree answers, but if it wants in radians, you put in radians. All right, so what am I doing here? 2w squared minus w minus 1. Split the middle term. 2 times negative 1 is negative 2. What factors of negative 2 add to negative 1? Negative 2 and 1. 2w squared minus 2w plus 1w minus 1. Group. Take out 2w, w minus 1. Take out a 1, w minus 1. So I get 2w plus 1, w minus 1. So w equals negative 1 over 2, w equals 1. And then I bring back in sine x equals negative 1/2, sine x equals 1. So we worked it all the way down so we can actually solve. So where Do we get a half and it's negative? Well, based on ASTC, we're in quadrant 3 and 4. Reference angle of 30 degrees. 7 pi over 6. 11 pi over 6. And where is sine going to be 1? Pi over 2. Okay. Minus 2 divided by rad 2. Cosecant x equals 2 over rad 2. Flip. Sine x equals rad 2 over 2. X equals 45 degrees. X equals 135 degrees. Alright, so secant x equals positive negative rad 4 over rad 3. Secant x equals positive negative 2 over rad 3. Secant x equals positive negative rad 3 over 2. Oh, my bad, not secant. I flipped it. Forgot to write, this should be cos of x. Alright, so cos of x, positive negative rad 3 over 2. Every single quadrant, 30 degrees. We got x equals pi over 6. We got 5 pi over 6. We got 7 pi over 6. We got 11 pi over 6. That's key in giving us our 30 degrees with cos. Alright, so scrolling through this worksheet right now. Alright, so this page, this is a good page to work on. This is basic. This is what we were looking at the other day that I was writing on the board. So take time, practice these basic ones. All the answers are up on the answer key. The answers are listed in radian, but if you did it in degree, that's fine. It doesn't really matter. Alright, so this section, good practice, work up to 12. This section, skip this, skip 13, 14, 15, 16, 17, and 18. And we'll jump to here. Alright, so these are definitely a little bit more challenging problems. And they're fine. You can do them. Right? So they're fine. So really the only ones I really want to talk about right now are these. So this problem here, secant x cosecant x equals 2 cosecant x. I like to clear the cutter. So I think like xy equals 2y. Alright, well, you know what? Subtract it over. And then how do I factor it? Well, GCF. And then, okay, that tells me y is 0, x equals 2. So I treated it as if I had variables. I worked on the algebra aspect, and now I could bring in the actual idea here. So the actual idea here is that in my setup, I said x equals secant, and I said y equals cosecant. So now I got cosecant x is 0, which means that sine x is, well, if I have 0 over 1 and I flip it, I have 1 over 0, that's undefined. That's giving me no answers. Alright, so let's also say now that I got y equals 2. Oh, I made a mistake somewhere, didn't I? No, my bad. Alright, so I got secant x equals 2. Flip it. Cos x equals 1/2. X equals, what are we talking about? 1/2. We're talking about 60 degrees, which is pi over 3. We're talking in the bottom quadrant, 5 pi over 3. Right, so I think being able to use a factoring technique to help break these down is key in these scenarios. Right? But not every problem do you have to factor. Understand that. And if I'm looking at this section, if I'm looking at which problems you got to factor, I would say this is a factoring problem, factoring problem, factoring problem, factoring problem. The ones up top, definitely not factoring problems. Alright, so to finish this off, I'm going to go through the bottom two. Alright, so I'm going 2x squared plus x minus 1 equals 0. Alright, I split the middle term, I go through that whole process. 2x minus 1, x plus 1, which means x equals 1/2, x equals -1. Sine x equals 1/2, sine x equals -1. So what does x actually equal? All right, so we're talking sine y value of a half. We got 30 degrees, which is pi over 6. We got second quadrant, 5 pi over 6. And if we're talking about -1, one's y -1, 270, 3 pi over 2. All right, move here, GCF tan, which gives me cosecant x minus 2 equals 0. So tan x equals 0, cosecant equals 2. All right, and that's telling me for tan, where's tan 0? 0 and 180 degrees. All right, well, cosecant we don't deal with, so I make it sine, and that's 1/2. All right, so where's sine 1/2? We're talking 30 degrees and 150 degrees. All right, so hopefully we all found this helpful. Hopefully we're all able to work through this and do the homework. I'll see you next class, and have a great weekend.